Magda, I'm sorry, you're muted.
Okay, so that might be better. Hello then, everyone. I'm very happy to be able to talk to you today about implicits and Scala free. So I have been a Scala developer for 5 years now. And right now I can say that Scala is a great language. I enjoy writing it every day. But the beginnings weren't so smooth. I kept struggling to understand various concepts of Scala. And one of the things that confused me the most was implicits. There were times where I thought, okay, I've got this. I understand implicits. But then I came across some other usage of it, and I had to go back to my more experienced colleagues and ask them, okay, I know we have talked about implicits, but can you please tell me one more time what happens here when implicits are used in this way, in this code? Fortunately, my colleagues were very patient. So I got through this difficult phase and I didn't give up Scala completely. But I kept thinking, why does it have to be so difficult? So when I heard about Scala free, and when I heard that in Scala free the concept of implicits was going to be completely redesigned, I got curious. I wanted to know if it's a change for the best. So this is how this presentation came to be. I would like to show to you what I have learned. So the plan for the next 35 minutes, let's say, is at first I will tell you what implicits are to remind you why you may need it in the first place. I will try to sum up what the biggest problems in Scala 2 was with implicits, at least for me. And then the main part of the presentation will be 7 use cases of code samples of contextual abstractions in Scala 2 and in Scala 3 to see exactly what has changed. And I will finish by saying a couple of words about migration. So let's start with talking about the implicits, our hero here. What are they for? So generally, implicit is a keyword in Scala which can be seen next to various language keywords, let's say, or parts. And it can mean many different things, actually. But what's common is that they define so-called contextual abstraction. So abstractions to about the context, because your code never actually runs in a void. It runs in some context. And because of that, sometimes you don't have to write and you don't want to write everything explicitly because the compiler can infer some of the things from the context to you because you decide it's not so important, so it doesn't have to be written explicitly. So apart from providing context, which is a very broad and general idea and the main part of it, implicits or the implicit keyword can be also used to add functionality to your code, to define type classes, which in itself have a are very important in the language, to provide implicit conversions between the types, to solve the issue of dependency injection, to express capabilities, compute new types, and prove to your compiler that there are some relationships between your types. And generally, implicits are a very powerful feature. They make us powerful because they let us make our code do what we need it to do. And it's also widely used in the code and in a lot of libraries in Scala. But at the same time, sometimes implicits make us miserable. And one of the reasons, in my opinion, why that's so, is that you can find this keyword next to various language constructs. So we can have implicit parameter, implicit argument, implicit value, object, method, and class. So it's not like you see the implicit keyword and you instantly know what's being defined here. You have to have the experience. You have to know and understand what the idioms are, what are the patterns in Scala to know what's the meaning of the implicit keyword here, or what's the intention of the author of the code. And another problem of implicits that happened a lot to me when I was learning is that imagine you have a piece of code, some class, it compiles, it works, it's great. You copy a bit of it to another class, and then the compiler isn't happy anymore. Something doesn't work. And then often you have to find the right implicit import because in that base class, there was a long list of imports, and one of that import actually fetched to you some implicit value which is needed by your code. So when you find which import it is, you find it and you copy it to the new place, the compiler is finally happy. So it often feels like magic. You have to find this magical import incantation, which will make your code compile and be great, because it will let you do what you want it to do. And the other problem, the other side of that, is that sometimes you import too much. So sometimes you don't even realize that in this long list of imports, you have some implicit value fetched. And for example, this could happen with conversions, so that you have some implicit conversions in the scope. So your compiler now treats some type as another type, and you don't even realize it. So this can also lead to confusion. So all of those reasons for me meant that Scala was hard to learn, and I think that can be one of the reasons why it's considered a difficult language. So what's different with Scala 3? Well, generally, as you may already know, Scala 3 is a major language rewrite. So it actually took 8 years from the first commit to the actual release of the language. But what's most important for me, what's meaningful, is that the creators of the language have listened to what we say. So they have looked at how the language is used. They have listened to our comments, our concerns, and our complaints. And their goal was to find and fix the tricky bits, the pain points, so that the language is more concise but more expressive at the same time, so that it's easier to work with in your day-to-day work. And it's probably not a surprise by now that implicits have been identified as one of such pain points. And the concept of implicits is redesigned, so much so that the implicit keyword is totally gone from the language. So you won't find it in Scala 3. What you get instead is you get a couple of new language constructs which do one thing and do it well. So let's now see what they are. The 7 use cases that I have provided is they are the providing context, so the most general idea, adding functionality to your code, defining type classes, implicit conversions, and then I will say a bit about implicit imports, about unused names, and about compiler errors. So this list here is not it's not a full, complete list of the differences, but these are the use cases which I consider the most practical or the most widely used that you might encounter and need the implicits for. So let's start with the use case of providing context. And on an example of defining a future. If you want to define a future in Scala, you can do it just like here at the bottom. So you just invoke the future with the body of the future. But you know that this cannot be enough, because if the future, so something happens asynchronously, you need to have some kind of a thread pool, in this case, execution context. So if you look actually at the method of the apply method on the future, and note that it's still traditional Scala 2, you will see that apart from the first parameter list with the body, you also have the second implicit parameter list with the execution context. But you don't have to include it here in your code, so it doesn't clutter the code. Because generally, in functional programming, you can have a lot of parameters in your methods, and that's good because you know what happens. But sometimes when it's too much, it can clutter your code. And it can mean that you don't see the things that are actually important because they change a lot, they have meaning. So that's why we decide that some of them, let's treat it as context. And if you want that code to work, you have to provide this context somewhere. And in Scala 2, you do it by providing an implicit value in scope. In this case, execution context.global. If we have it somewhere in the scope, then our future will work this way. So now that implicit keyword is gone from Scala 3, what do we have? How do we write this kind of future in Scala 3? The code at the bottom is the same, but if you look at the definition of the apply method in the future, it will look a bit different. It uses the using keyword. So it says that here, if you want this is the definition of our method, and it needs to use an executor value of the execution context type. And in the place where you need to provide it, you use the given keyword. So instead of having implicit mean two different things, you now have a pair of keywords, using and given. And this is the most important thing for you. And this using given pair will be something that you use a lot in Scala 3. The most the main concept for contextual abstractions. But now let's move on. And the second use case is adding functionality. So to say what we really want to achieve here, let's find an example. So let's say that we are in the business. Our sample domain is the business of preparing a website about books, a social website where you can add the books that you have read and see what your friends have read and so on. And there's also the concept of reading challenges. So you can define and decide in January that this year you want to read 6 books or 12 books or 20 books, and then you add the books you have read and you see if you are on track or not. And this is, let's say this is working great, but then it turns out that some of the users add books which are very short, like 5 pages long, and then they have this enormous reading challenges which they finish in January, and it's not so much fun for everybody anymore. So we decide that we want to add a new functionality, and we want to say whether a book qualifies for a challenge or not. It only qualifies if it's longer than 20 pages. So we would like to have a method which would operate on the book type called qualifies for challenge. However, our problem is that our book type is a closed type for us. It's somewhere there in another package, in another library. Maybe it belongs to another team, so we cannot really extend it easily. We cannot make changes to it. So for this reason, to add functionality to a closed type, in Scala 2, you could use implicit classes. This is how it would look like. You define an implicit class, you give it a name, even though it doesn't matter. It operates on the book type, and the definition of the method is it returns true if the number of pages is more than 20. And if in Scala 2 you have such an implicit class defined in scope, then the code at the bottom will compile and will work for you as you expect. Now let's see what's different in Scala 3. We still have the same code at the bottom, which we would like to be able to invoke, and we still have the closed book type. And the way we define it in Scala 3 is extension methods. So this extension here is a special new Scala keyword. You define it this way, you write extension, it operates on the type book, and then you add the method which you want to add. So you no longer use the implicit keyword. But what's great here is that this is a good example of a feature which does one thing and do it well. So what it means, if right now you take a look at the code, you see the extension keyword, you instantly know what's happening here. You know that this is adding functionality, some new methods to a closed type. So in my opinion, that's very clear. And now let's move to type classes. So generally, type classes are a very powerful and very important feature in many languages, and also in Scala. And to illustrate generally what you might use it for, even for Scala 2, let's say we are still in our domain of book challenges, and then our users came to us saying that they don't read so many books, but they read a lot of articles, and they would like to take part in our challenges as well. But how do you compare it? How do you compare, because reading 6 books is not the same as reading 6 articles and so on. So how can this work together? So we define that you just need to score them differently, so that you will score the books according to the number of pages they have, and that the articles is always worth 1 point, because it's hard to decide how many pages an article has. So we would like to write the following code as it's here at the bottom. So you have the book type, you keep current score, and if you add a book, then your current score will be 600 for Dune. But if you add an article type, an instance of an article, your next score is 601. So how can you achieve it? If only book and article had a common parent, then we could common parent or a trait, we could define some kind of a score method in it and let the subtypes implement it accordingly to what the logic should be for each of them. But unfortunately, in this case, it's not like that. They are two totally unrelated types. We cannot make changes to them, we cannot make them implement any traits, and so on. So what do we do? This is where type classes can come in. Type classes can help you if you need to define so-called ad hoc polymorphism. So we want to add some behavior to unrelated types. And the way you do it in Scala 2, traditionally, you define a scorable trait, in our case scorable, but you define a trait with a method in it. The trait is parameterized by the types, by the type, which will need to support this behavior. And the way we use it is we have to define an implementation of this trait, so an implementation of the type class for each of the types, for book and for article. So you have a scorable parameterized by the book type, and the definition for the book is to return the number of pages. And you have the scorable behavior or trait implemented in the type class parameterized by the article type, in which the implementation it's always worth 1 point. And when you want to, the way you use such type classes is, for example, here, you have this current score case class, which stores the current value of our yearly score. And you have a method which you say that operates on a type, which has the scorable behavior. So this T colon scorable is context bounds. It's called context bounds in Scala. And this way you can say that this method can work on any item which has the scorable behavior. And the implementation of this method in our case is it creates the new current score, taking the value so far. And then this implicitly of scorable is a way to tell the compiler, please fetch me the right type class for the type that I was called with. So it will either fetch this one or the other one and invoke the appropriate score method on that. So this is Scala 2. And actually, in Scala 2, instead of implicit vals, you can also define type classes with implicit objects or defs. And if you don't like this implicitly, this syntax, then you can also write it in a different way. And you might have seen this. Is you can have another parameter list which has the scoring parameter named here, implicit scoring. So you can invoke it on a named parameter. So this is Scala 2. Now let's see Scala 3. The code here so far is the same, so we want to use it the same way, and the trait, the behavior is defined the same way, so scorable parameterized by the T. But we are using our known pair of given and using for that. So to implement our type classes, we use the given keyword. We define scorable of type book and scorable of type article. And the way we use it in the current score case class is here. This one doesn't change. It's still context bounds, the same as Scala 2. And here, this implicitly was changed to summon, because even for such a simple thing, the implicit keyword is gone, and it's consistent. It's now called summon. So it's a specific keyword which you instantly know that you want to fetch the appropriate, in this case, type class, and then invoke the score method on that. And again, if you don't like the context bounds and you prefer to have an implicit parameter list, then you have this using clause here, where you have a named parameter which you can use. So this is how you define type classes in Scala free. Now let's move on to implicit conversions. Let's say you want to have the code at the bottom. So you have a book and you want to print it. And let's imagine that we have this unique, special, very special method and definition of the print method here, but it operates on the item type. There's some other item type in our system. And again, it's a closed type. We cannot change it and we cannot change the print method. But somehow we would like to still use that print method on a book type. And this is where implicit conversions can be helpful. So we want to say to the compiler, wherever you see a book and you expect an item, this is your definition of how to do it. And this is still traditional Scala 2. So the way you do it in Scala 2 is you provide an implicit def, an implicit method. The name isn't important, but it operates on the book type and it returns an item type. And here is our definition. We say to the compiler, just use the item constructor. And if you have such an implicit, such a method in scope, then you will be able to write the code here at the bottom. Your compiler will know how to convert it implicitly for you. And how is it different in Scala free? The code here is the same. We want to achieve the same thing, but we have a conversion. So we use the given, as we already know, but we also have a special class. It's a Scala.conversion class parameterized by two types, source and target. So in our case, book and item. And it has one method that you need to implement. And this is the apply method. So here is our definition. And this way we can treat books as items. But what's important here is that, again, you have a specific feature or a class for this one use case. So whenever you see the conversion class, Scala.conversion, parameterized by the two types, you know that what happens here is you are defining an implicit conversion for the compiler. So this makes the implicit conversions a bit more explicit for you. So it's harder to get confused by that. And now, if we're talking about confusion, let's talk a bit about imports. So in Scala 2, this is normal code. This compiles. You have a future, you import something from the implicits package, and behind the scenes, your compiler will fetch from it the implicit value of execution context, as we saw in the first example. But in Scala free, the same code won't compile. It will give you compilation error. Why is that? Is that actually, if you want to import an implicit, so a given, then you want to use this, you need to use this special syntax, implicits.given, because this implicits.asterisk, what it will do is it will import everything apart from the given instances. And if you do want to import givens, you need to do it like this. And what you achieve by that is that right now, if you have some base class, you know it works, it has a long list of imports, and you copy some code away from that, and it stops compiling because you are missing some given or some implicit, you can easily find it, because here in the base class, in the long list of imports, there will be a couple which end with the .given. So these are your candidates to look for bringing back or fetching to your code. So this also makes the implicit imports a bit more explicit, a bit more useful or easier to work with. And if you do want to really import everything from a package, that's also possible. You just need to use this syntax, so this given, comma, asterisk. And then it will really import everything from that package for you, if that's what you want. Now, one of my favorite things, even though it's very small, it's about unused names. So let's say that in our domain, we have a sequence of books and we want to sort it. So we don't want to reinvent the wheel. We would prefer to use something that's built in. And actually in the substrate, there's a sorted method which you can use. But for that, you need in Scala 2 to provide an implicit ordering. Because out of the box, the compiler doesn't know, where the compiler will tell you that it doesn't know how to order the books. Should it be according to the title or to the number of pages or something else? So what you do in Scala 2, you provide an implicit value. So it's the ordering parameterized by the book type, and the implementation is just that for two books, you just compare their titles. But this thing by title, notice that it's not used anywhere here. The compiler can find it because it finds it by the type. So the compiler has the types, it's happy, but we still have to think of a name that we don't use. And in Scala 3, you can do it a similar way. So we have a sequence of books. You invoke the sorted method from the substrate. And here you have the new keyword that you already know. Still, you have to provide the ordering. And then using a given instance or a given value, you can provide the name, but you don't have to, because the second thing will, the second piece of code will also work. The compiler knows what it needs because it has the types. And I like this because naming things is difficult in programming. And even though it doesn't matter, you have to think of it. So you have to talk to your colleagues. Do you give one-letter names, or do you do some convention, or do you provide meaningful titles? Right now, the code is more concise. If you decide that it doesn't add anything to your code, you don't have to include it. If you want to, if you have this perfect name which is helpful for the readers, go on, but you don't have to. So that's a small but nice thing. And the last comparison is compiler errors. So in Scala 2, when you were missing some import, the compiler was a little bit helpful, but not so much. So it said, for example, that it could not find implicit value for the parameter called evidence, here in this case, and this parameter should be of type scorable, parameterized by the book. So you know what is missing, but you don't know where. And sometimes it's not instantly obvious where it's missing, because maybe you have a long chain of method calls and you're not sure which of the methods need an implicit at all. So for Scala 3, this has improved. So you not only know what is missing, but you exactly know where. Is the, here in this case, the scoring parameter of the add item method of the current score class. So it's much easier to find it. And if that's not enough, sometimes the compiler will try to be extra helpful, and it will add a suggestion of an import which might actually fix your problem. So for the trivial ones, like needing an execution context or things like that, it can be helpful. So it's again a small thing, but you are missing this, you forgot about this, you have the suggestion from the compiler, you add the import, and you go on with coding. So it doesn't stop you. It doesn't make you lose context and think about what you are missing and so on. It's just easier in our day-to-day work. So now that we have the 7 differences and we know how to use that, how should we migrate? If I said that the implicit keyword is gone altogether, but on the other hand, it's so widely used in the existing code, then does it have to be a big rewrite for us, for the users? Fortunately, there is a grace period. And for this time, implicits and the given and using pair can be used together. So at least for 3.0 and 3.1, we can use both, which means that, for example, you can have your code which is already migrated to the given and using pair, and it can use a library or a code from some other package which still uses implicits. it will be translated. It will work together happily. And at the same time, you can start to use code that is already migrated and defined using the using clauses, but still your code has implicits, but it will still work. So we can do it gradually, bit by bit. To sum up, the most important thing for me as a user of Scala for contextual abstractions is that right now it's easier to reason about or to read the intention and not the mechanism of the code. So as a writer, you say what you want to achieve and not how you want to achieve it, which seems to be also along the lines of functional programming principles. So now that you have the new given and using keywords, the extension methods, and the Scala.conversion class, and with more helpful compiler errors and clearer imports, I think Scala, in terms of contextual abstractions, writing contextual abstractions in Scala 3 is a bit more expressive. It's easier to get it right from the first time. And it's also more convenient and much more pleasurable to work with when you are reading new code and you're trying to just find out what it does. If you would like to know more about the topic, one thing that I haven't mentioned is context functions. I haven't mentioned it because it's a new thing in Scala 3, so it doesn't have a direct counterpart in Scala 2. But it's a very powerful feature, so you should have a look at that as well. And if you would like to know about other Scala 3 features and improvements, then the Scala docs are pretty nicely written, so they will guide you through all the changes. And for example, the syntax changes that you may have noticed, the white spaces and the curly braces, which you don't have to include, it will be all here. And when you are ready to migrate, there's also a migration guide, which will lead you step by step of the things and the feature flags, the compiler flags that you might want to use to make the migration. And all the examples from these presentations are gathered in two GitHub repositories. One is for Scala 2 and the other for Scala 3. So you can run them both together if you'd like to play around with it, see how the compiler reacts to changes, and so on. So that's all. If you have any feedback, then you can scan the QR code below or go to the link there below. It also includes the link to these slides. And if you have any questions, I will be happy to take them now.
Thank you, Magda. I think we have a couple questions for you, so let's get into the first question. Are given/using do the same recursive resolutions as implicits in Scala 2?
So if it's about the rules according to how the compiler resolve which values are in the context or not, I think there were substantial changes, and yeah, it's a bit different. So you need to take a look at that.
Excellent. All right. Next question. Extremely clear and well explained.
Thanks.
Are there any common usages of Scala 2 implicits that aren't covered by the new given/using syntax?
Well, in my opinion, the most important parts were included in the presentation, but those that aren't covered. So I think you'd need to take a look at this link for the Scala 3 migration, because it has more. It explains more that I have covered here, and you can have a look at the Scala 2 use cases, so that there's more than I have explained, and see how they differ in Scala 3. Or you can do the other way around and look at the Scala 3 features and see how you would implement such a thing in Scala 2. So maybe more edge cases can be found there.
Great. Well, I think that's all the questions we have today. So thank you so much for your presentation. Thank you for being here, and enjoy the rest of the conference.
I will. Thanks.
Fire in retro rock. Roger, Matt. Ready to eject.